Hello, and welcome to my talk. I'm going to speak about testing multi-OS Python software. And this is the structure of my talk. First of all, there will be a short introduction. Then I'm going to showcase how to do unit testing in Python at the example of the two major frameworks. After that, I'm going to speak about how to automate tests and how to use these testing frameworks in an automated environment. And in the end, I'm going to wrap up with some general tips and techniques on how to develop software, how to use tests, and some more general things about that topic. And this is from my personal experience and not necessarily textbook stuff, but all right, about myself. I have a computer science degree and I'm currently working at UIB company in Mainz. And I'm working as a software developer, as you may have guessed, and I'm part of the backend team of the gitlab-ci project. You may want to check that link out. It's, gitlab-ci is an open source tool for client management, patch management, configuration management, and so on. Also, we have you can find us over there. And in general, I love to automate things and have simple and robust and reproducible workflows. And this is something that, I really strive for. So, software testing. Software testing in general, why do we do that? To find bugs, obviously. We want to have software run smoothly. We don't want any unexpected results. And to ensure that, we write tests. And this is only the first thing. The second thing is to if you have a lot of tests and you have a good coverage, then you may change your code, restructure things, change the logic or the order of things, and you see whether you break things or if things still work as expected. And the third thing is to be robust against input of any kind. Usually, applications process any kind of input, and this may be there may be the case where input is crafted in a malicious way, trying to break your application, or just plain stupid. In both cases, you want to be robust against that. And there's this nice quote: "Programming today is a race between software engineers striving to build bigger and better idiot-proof programs, and the universe trying to produce bigger and better idiots. So far, the universe is winning." This is by Rick Cook. It's an author who sadly passed away last year. So we want to do software testing. There are different types of testing. The first type is the one which I will mainly focus on in this talk. It's unit testing. Unit testing focuses on single things, so classes, functions, contained elements of your application, and you want to check these one by one and try if some inputs produce the expected outputs. Then there's integration testing, which is can be considered as the next level of testing, where you have multiple elements of your application and you try to test them against each other. So you check the interfaces between them and whether they collaborate in a way you want them to collaborate. And then there's end-to-end testing, which is the overarching thing, testing one workflow or task from start to finish over all involved components and check whether you get the expected result. And as I said, here I'm focusing on unit testing, and specifically unit testing for Python. Most concepts may be generalized, but the two frameworks I'm going to show are Python frameworks. So this is the focus. All right, unit tests in Python. There is two major frameworks, as I said. One of them is pytest. Pytest is probably the most known of them, and it is a command line tool. It handles a set of test scenarios, which are can be collected in a directory, and they can be structured and so on. But basically, you have a directory where you have some test code, and this test code is executed. The single tests are executed one by one and evaluated, and in the end you get two things, basically, a human readable summary, whether you passed or failed, or the tests passed or failed, with some information, why, where, how any test failed, so at which point things broke, or so on, things that would help you to debug. And the second thing you get is a coverage file, which is machine readable, and it basically shows line by line of your original code that you want to test, which of these lines has been successfully tested and which hasn't. And this helps you to spot functions or elements that you still have to test, or where there are holes in your testing. This can be interpreted by some tools, and I will talk about that later. So pytest. Pytest is useful for testing simple contained things, or can be used for testing a whole project. But the focus is to have a single class that is being tested, or a single method, and so on. And you can use some nice features to, as quality of life improvements. You can parameterize tests, so you can have the same test with different sets of input parameters, and you can use that to check a wide range of possible input values, or different things to cover. And you can also use markers to direct which tests are executed and in which way. So you can differentiate between operating systems, architectures, any kind of variables that your testing system might offer. And so you can fine-tune or decide which is done how. And I'm going to show an example. First, a very simple one. Given this function, so we have here this function obfuscate. This basically takes an input string and produces another string as output. And it basically shifts any character in the input string by this function, and produces another output string by that. And this function here is just a function that shifts any letter in the alphabet by 13 positions. So ROT13 or Caesar encryption of level 13 is, this is how it's called. And it's basically some kind of low-level encryption. I don't want to use the term encryption here, so let's say obfuscation. And this is a way to produce text that is not really readable as long as you don't know which method created that text. So and because our alphabet has 26 letters, we can simply apply this function twice, and we get, again, our input value. So shifting by 13 and then 13 again yields the original input. And yeah, you can use that. It's a funny thing to use, but please don't use it in production. You may want to use it in, I don't know, your love letters, whatever. But yeah, this is not a proper encryption. Just side note. Yeah, so we want to write a test for that. And yeah, here first we import our function. This is the function you saw before. And we have this testing function. And there are two statements. The first one explicitly calls the function on the input string hello world. And we check, this assert statement checks whether this equality is given. And basically this is what we would expect when shifting every letter by 13 positions. So very simple check. The second line just checks the other property that I just mentioned, whether the obfuscation of the obfuscation is the input again. So what do we get here? We execute this and we see this works. The test passed. Here we get this small summary, which is quite boring for the simple test, but anyway, you see a headline, you see some version information, you see a path, any plugins, and then you see the tests that have been run, so directory and file where the test is located, and then here you probably won't see that. Okay, there's a small green dot, meaning everything all right, the test passed. In case there are more than one test in here, you will see multiple characters here, and it is a green dot for a passed test and a red F for a failed test. And if all tests pass, then there's this nice green line. Always happy to see that. And you see that everything's all right. So second example. So the question was whether the test really passed, because there are lower and uppercase letters. And yes, it does pass, because, maybe I should have explained it more in depth, because every letter or every character in the upper line is translated to the character in the lower line. So a capital A becomes a capital N, and a lowercase a becomes a lowercase n. So if you apply the same function again, then the lowercase n becomes a lowercase a again. Yeah. All right. Second example. Here we make use of the parameterize decorator. Here you can see this add pytest mark parameterize thing. This is a mechanism which introduces any of the pairs to the input parameters. So now our test function, test example 2, has two input parameters, data and result. Data being our input and result being the thing that we expect as our output. And here we say the first thing should be mapped to data and the second thing should be mapped to result. And we do this for 3 pairs here. So hello world should be mapped to the thing we had before. Then there's this sentence and also another string there. And we get what we would expect. Now we have 3 dots here, 3 passed tests, and everything's all right. Third example. Now we want to check the property that I mentioned for general strings. So here we want to check whether any word, I spaced this by words, which is in the input does not appear in the output. And here again, we have two input values being mapped to this data thing. And we apply this. And for the first, it works. For the second, obviously, it doesn't. And you can see that here. I don't know if you can see the red. All right. First of all, you can see the first test passed. There's this green dot, and then the second test failed. And here you have a summary of failures. You get which was used as parameters. So our data parameter is this input string we used. You can see the function here again. You can see the line where the test failed. And you see here the assertion error, assert, and then this telephone number was not in the obfuscated output. And this failed because the telephone number does not contain any letter characters, and there was no defined change for digits, so the digits remain the same in the output. And this is the result. So here we have the failed test, and we can use the information here to think about how we could improve our obfuscation function, or at least we get information we need for debugging the problem in any way. And there you see that you should not use this obfuscation, maybe not even for love letters. So the second thing, the second major, or the second Python framework for unit testing that I want to showcase here is Hypothesis. And there's this joke about software testing. A software tester walks into a bar, crawls into a bar, dances into a bar, flies into a bar, and orders a beer, 999 million beers, 0 beers, a lizard in a beer glass, -1 beer, QWERTY beers, and so on. Software testing complete. A real customer walks into a bar and asks where the bathroom is, and the bar goes up in flames. So the message here is that you should think about what you can expect as input data, and you should have a plan on how to handle any of that. And this is basically what hypothesis does. You first define what you expect as input data. So for every function, you check what type of data you accept. And then or hypothesis helps you to check against any or arbitrary patterns following that scheme. So if you want to check against strings, then hypothesis will craft some strings and check your function against that. And there's a very nice documentation, which I recommend you to read if you want to try it out. Or at least take a look at it. And it is useful for identifying problematic input. Again, this covers both cases where there's just stupid input or maliciously crafted input. So any input that may make your application break, hypothesis helps you to identify that. And it does that by checking against extreme instances of these types. And for example, for integer numbers, it checks against negative or very large, very small, or 0, of course. And for strings, there are empty strings, long strings, special characters, paths. There you have relative or absolute paths in Windows or POSIX style, for example, and spaces, spaces, backslashes, or any kind of things that you shouldn't use in path names. And it tries against that. And here's an example. So we come back to this obfuscation function we defined before. And now we need some more imports from Hypothesis, which is just a Python module that you can install. or a library. You can import given and strategies. Given is a decorator, you can see here, which is responsible for filling the input here with anything. And this anything is defined by this second import, strategies. Here we use strategies.characters. So this is a strategy in hypothesis speak. And it is something that creates an arbitrary number of strings that are crafted in a way that they might be problematic. And yeah, here we have this function. We want to check whether the obfuscation of the obfuscation is the input again, and also we want to check whether no input produces the same output. So chars is the string here. And as we saw in the previous example, this fails. Same thing, basically. Here it tried, or let's start above here. You can see there's only one test that is shown here. That is not really the case, but it is how pytest displays this. So there have been multiple different strings that have been crafted and tested against this function, but it is displayed as 1, and it failed. And the thing that failed was the input value 0. As you previously saw, 0 obfuscated with this function is 0 again. So we get the same thing here. And yeah, we don't really know what kind of values hypothesis tried. This is can be considered problematic for reproducibility or anything like that, but it is impressively accurate with finding devious things. So second example. Now we move away from our obfuscation function, which we proved rather useless, and now we want to check whether integers are commutative. So if x plus y is always the same as y plus x. So here again we have this given decorator. We use 2 values now. The first being crafted from integers or strategies.integers, and the second as well. So we get 2 integers, any integers, and we want to check that. And we get, yes, integers are indeed commutative. No real surprise here. And what happens if we check the same thing with floats? So same thing. We have 2 floats that we create here. And we check whether x plus y is the same as y plus x. And the result is that it isn't. This may be a surprise for some. For me, at least, it was. Mathematically speaking, that should be the case. But for Python floats, there are some special values. Here you get this example, the example where it failed. You have x being infinity and y being minus infinity. And infinity plus minus infinity isn't 0. It is not a number. And now you have not a number, and you want to check it against not a number. And this is false, because any comparison with not a number has the result false. So you cannot compare anything against not a number in Python. So this is hypothesis, and now I'm going to talk about how to automate tests. So testing in itself is pretty useful. You can use it to check whatever you just wrote, or I don't know, anything. But it's very, very useful to use it in an automated way. And for that, GitLab-ci is one way of doing that. First of all, Git is a very powerful tool. I recommend using that for any kind of development purposes. You probably know it. And there's GitLab, which you maybe also know. They're an open source software development platform. You can see the website over there. And yeah, it offers ways to collaboratively to use it together to write software and to collaboratively develop things. And it has this mechanism, gitlab-ci, which runs a defined set of operations on every push. So every time you push some new commits to GitLab, it does things, and you can define what it does. By writing a pipeline. Pipeline is a series of jobs, and these jobs consist of actions, and these actions are basically just shell commands, or can be any shell, bash, or even PowerShell, or anything. And you can define this as kind of a shell script, and this is executed every time, and it is executed line by line as long as the exit code of the previous command is 0. So as long as everything is okay, it continues, and if anything is not okay, then it breaks and it counts as failed, and you get a notification. And if you want to have more information on that topic, I recommend the talk by Errol Ulikman, who is the CEO of my company. And previous year he had this talk here at FrOSCon, and you can find it there. So, as I said, it executes commands as long as the exit code is 0. And pytest, luckily, produces exit code 1 if any test fails. So if at least one test fails, the exit code will be 1, and the GitLab-ci pipeline counts as failed. That means that other further steps that you may include there are not triggered. So, for example, if you automatically ship to another testing environment or even to production, then this is not triggered if any test fails. And also the author of the commit is notified, so that can be useful for noticing at least any errors. Python is great for writing multi-platform apps, because for very, very many platforms there is a Python interpreter which you can use. And you basically have, for the core functionality, you can use the same code for Windows, Linux, Mac, whatever, Intel or ARM, anything. And typically you want to develop on one, probably your favorite platform, and then you ship the result to many platforms. And of course you want to test that. And as there are fundamental differences between platforms, you should test on all of them if possible. So, for example, in the POSIX world, you have many things being handled with configuration files. In the Windows world, you use the registry, and also handling of network shares and files, users, permissions, shared resources. There are differences, and you should check for that. So How can you check for that? Some functionality can be mocked. Mocking meaning you simulate a part of reality and you basically write something that behaves as if it was something else. So you can, for example, mock a web server by having this small contained thing that acts like one, but you can still run the test without any network access. So just having this one component that mimics a web server. But yeah, you can also mock some functions of different target platforms, but that is not ideal. In the ideal scenario, you should really test on the target platform because yeah, no simulation is as close to the truth as the truth, obviously. So yeah, you should really run tests on different platforms. And for Linux, this is pretty easy. You can use Docker containers for running on basically whatever you want to you want to use. And for Windows and macOS, this is a bit more complicated. But yeah, what we use are virtual machines there. So we have a dedicated virtual machine for each platform that we want to test, each Windows and macOS platform. And yeah, there you can run the tests. And you can use gitlab-ci for that, basically defining a job for each target platform. And yeah, what it does is it ships your changes to the dedicated machine or container, and then it executes pytest there within that specific environment, and yeah, creates results in the machine-readable format, stores it as a pipeline artifact. So in gitlab-ci, you can have artifacts which are files basically that are can be used by other jobs. So you can ship your result to the next job, and the next job collects all of these and combines the results. So you have single coverages from all the target platforms, and the final job of the pipeline can combine them into one coverage thing and also print a human-readable summary. And here I have an example of that. This is actually a real-world example, or at least up until this vertical line. Here you can see a software component, OPSI CLI, and you can see what pytest produces. This is, yeah, you get this nice table where you get here the number of total statements which are in that Python module. And you get how many of these are missed by the test, and then it computes the overall coverage. So in the final line, there's this summary of the summary. You get the total number of statements, the ones that have been missed, and the coverage, which is here 85%. And yeah, on the right-hand side, you see a similar output, which is the one produced by a test for one specific platform. This is for one Windows platform. Basically the same things, just different numbers. And here you can see that for some of the modules, yeah, some tests are executed on Windows, or some statements are executed on Windows, and others are on POSIX, Linux, macOS, whatever. And so this number will always be smaller than the total thing. And the total thing is just, yeah, all these coverages combined. And yeah, as you can see here, 85% test coverage. You want to have as much as possible. It is kind of, yeah, very, very tedious or close to impossible to get 100%. But yeah, you should strive for something rather close to that. So yeah. Okay. Yeah. Now I'm going to speak about some general tips and techniques. And the first thing is test-driven development. I'm not saying that you should use that, but it is something you should have in mind when writing an application and considering writing tests for that. So test-driven development is basically the reversed workflow of the classical testing thing. And it works in the way that you first think about what you want to do, define tasks, and then formulate how to want to wrap them in classes and functions. And then you write tests for each of these classes and functions, even though they do not exist yet. And only the last step is to implement the actual classes and functions, and you want them to implement them in a way that the tests pass. This is something that helps you or can help you to focus on, first of all, focus on really thinking it through, what you want to achieve and how. And then it also helps with a good test coverage if you test every functionality really before beginning to implement it. Second thing, completely unrelated, use Git branches. As I said before, Git is a powerful tool. If you don't use it and have something to do with software development, you should really check it out. And it not only offers ways to have version control over your code and collaboratively work on that, but it also has the possibility to use branches. A branch is basically a parallel state of the repository. So you can have one main branch that is always there, that always works. And if you want to implement a new feature, or even if you want to write a fix, which is maybe a bit more complicated, you should branch from the main branch and have a second parallel state. And there you can development your stuff, you can write tests, you can work on that until it is finished. And only after it is finished, it works, all the tests pass, you open a merge request to then again unify these states and create the new main branch. And this way you can have your main branch always ready for release in case you have to release somehow. And the other thing is that you could use the principle of 4 eyes. So every change in this workflow is seen by at least 2 developers, which helps finding some small mistakes from typos to bigger things. So it really reduces the error rate, I would say. Next thing, now specifically about Python, you should use virtual environments. So Python environments or virtual environments are isolated from your system. If you are running or working on a POSIX system, you will probably already have a Python Python in your system, and you shouldn't really meddle with that. So having a isolated, separated instance helps you to on the one hand, you can work with it without breaking your system Python. So you can install, uninstall anything, and you are sure to not break anything else. And also, it gives you a small environment which really only contains what your application needs. And there are some frameworks that can help you with that. First thing is venv, and it is very basic. And the other two are based on venv, so they are using the first one, but they offer some more convenience functions. They are very flexible and can tailor your environment to your needs. Then use IDEs. For many years, I was very skeptical of heavy IDEs doing things that I don't understand without notifying me or anything like that. But it is really useful to use integrated development environments. And there are some features that I find particularly helpful. First is development containers or dev containers. These things are basically the next step from virtual environments. They do not only have an isolated Python, but also have an isolated system, operating system around that. So you have a container, Linux container, in which your development process takes place. And second useful feature is go-to definition. So usually if you have your code open there, you can click with Control or Shift or depending on configuration and IDE, you can click on that and find where that specific object is defined. So if you have an instance of an object, you can find the class definition or the definition, the initiation of that object. And this also works for dependencies. So if you're using external libraries, you're using a function of that, you can just click on the function and you see the definition of the function, even though it is not within the code you wrote. And then there are two plugins. Coverage Gutter, which is pretty useful for displaying the pytest coverage files that I mentioned before. And this is what you can see in this upper example here. Here you can see there's this colored bar. Green means the line has been tested, and nothing means there is nothing, and red means the line has not been tested. So this I can use to identify parts of the code that I should write tests for, because it is unchecked. So in this case, this is again a real-world example. Here, apparently, we didn't check for the case where our file object we want to create points to a path that doesn't exist. Then Git marker. As I said, Git is quite nice, and there are plugins that can help you with developing with Git. And here you can see also this colored lines. Green meaning the line is new. So after the last commit, apparently I added this line here. Red means there something was deleted there, so at least one line, one or more. And blue means the line has been changed since the last commit. Okay. Also use linters. Linters are a tool to check the format of what you are writing, and it also helps you to find some small bugs or possible problems. I'm not going into detail on that, but there are some examples here that you can use. Finding some whatever things that might be problematic, and some of the linters are capable of automatically correcting these things, but of course you have to be careful with that. Then use type hints, also very Python specific. Python itself isn't statically typed, it is dynamically typed. You can have a variable pointing to different objects or objects of different types, and you have to be careful with that. In this example here, you have a function that just outputs the length of whatever is the input, and you can use it on a string, that works. You could also use it on a list. Then it would output the number of elements in that list. But if you want to use it on this integer number, then it breaks. So this is an exception at runtime. If you use type hints, you can add this colon and then type. So here we explicitly expect a string, and we want to create, or the function returns an integer. We have basically the same thing. This will still be an exception at runtime, but on this statement, your IDE will probably warn you, because it knows that this function expects a string, and this isn't a string. Yeah, and the last thing, do not reinvent the wheel. Python has a very large community and very, very many great libraries. There are thousands of cool repositories with libraries, with functions you can use. So if you want to implement a thing, you should at least take a look around and see if it already has been done and if you can use that. And there is this public catalog at pypi.org. And you can check there for, or there's a search interface. You can see if there's anything you can use. Also, Python has a nice standard library, which is extended from version to version. So you should always try to use a rather up-to-date Python version. And with anything, if you spot a problem with an external component, being in the standard library or more likely in any of the libraries you find on PyPI or anywhere else, please do not just work around the problem. Report the problem, open an issue, or usually they have an GitHub, GitLab, Bitbucket, whatever page where you can report what you found. And usually the developers are very glad if you do so, and are happy to fix the thing. So please do that. And that is it. And thank you for your attention. Are there any questions? The question was whether my slides will be online. I think so. I don't know. I uploaded them to the FrOSCon wrap interface. Okay. Okay. So the slides are online. Yeah.
What's basically the implication on testing times when using strategies and how much slower it doesn't get from your experience?
The question was how much this hypothesis framework affects testing times. And it really depends, as always. If you're using a function which has not one or two, but many inputs, then this really has a negative impact on the execution time of the test. I cannot quantify here, but it's more suited for functions that only have a handful of inputs. Yes? Okay, the question was why the coverages that I showed differ from one platform to the others. And yes, there is platform-specific code there. For example, I don't know, in this here, OPSI CLI, this specific tool does a lot of things that are operating system dependent. So I don't know, what do we have here? Yeah, yeah. Yeah, one big example is just how configuration is stored. Yeah, on POSIX we have configuration files, user and system specific, and we store them in, I don't know, /etc somewhere, or home directory .config somewhere. And for Windows, this is handled completely different, in a completely different way. So there we load some registry part and, yeah, find things there. Yeah.
Is the only coverage you can measure like statements, or you have others coverage
The question was whether this was the only type of coverage one can measure, so statement by statement. And I don't know. This is the thing that pytest automatically creates. There are a lot of plugins for pytest. I would be surprised if there wasn't something that would use different metrics to evaluate coverage, but I'm not sure. It would be interesting. Good idea.
Could you show the slide where you use this framework with assertions?
You mean this this one, or? Mm-hmm.
So I think somewhere in that assertion using for the generation you use integer or
Yeah, this was in the hypothesis example. Here. You mean that?
yes.
It's probably hard to read.
So
Yeah.
if you have floating and integers together, is it possible to specify those strategies for those?
Yeah.
Integer and y is float.
Yeah. Yeah. You can. The question was whether you can mix different strategies here, and the answer is yes. I didn't show it in the talk, but yes, you can. You can use any combination of the given strategies generators, and you can also define your own strategies. So you can. You could also create a strategy that would randomly create integers and floats, for example. Yes. Yeah.
Show the example of the CI/CD pipeline of GitLab.
Mm-hmm.
If the test fails, wouldn't it be smarter to stop the push command, because otherwise, you're pushing failed code, which might have an error.
Mm-hmm. The question was whether on a GitLab CI pipeline you should not. You should stop the pipeline after a failed job to not execute the following stages. And yes, that is exactly what it automatically does. So if any job fails in a stage, then the next stage is not executed.
But the push is executed, so the failed code is in the repository, or is the push stopped?
Okay. I misunderstood your question. The question was whether to push code to the remote repository even if the test failed. And yeah, that is an interesting thing. If you want to use GitLab CI, you already have pushed your code. So the stuff is executed after the repository has been updated. And this is necessary because all the machines you run your tests on have to pull this change. But you can use another mechanism. You can use a Git hook, a hook to locally execute tests before any push operation. And there you can define an abort condition where you can say, if any test fails, then I do not push my code to the remote GitLab instance. But this obviously only tests my platform. So
It always works on my machine.
yeah, yeah, always works on my machine. Yes. Okay. Any more questions? All right. Then I would say, have a nice rest of the conference.